photo paper for the...
I did my little presentation on the wonders of step motors. It's a nice little title page that Professor Fiala asked for. I used sort of an example step motor that I no longer have because it got crushed, but I had the manual, so it had a lot of information. It's a step motor with the driver on there, so that's why it's all in one piece. You don't always buy them in one piece. But the cool thing is that with these ones is that there's a digital part where you can program it, and then there's an analog part where you can use it as sort of like as an input for sensors, or turn it on and off if you want this motor off or anything like that. So this is a little thing I found on Wikipedia. It just shows the internal mechanics. So it's just, this one is for electromagnets, and they go on in order, and there's like little teeth, and that's there's like micro steps and there's larger steps, and as they turn on, one of the steps will go across. So like one turn might have on a specific step motor like 300 micro steps, but maybe 30 regular steps. So if you want, like if you're measuring how far something's going, let's say you're making a robot, you might want it to go, you might want it, the wheel to turn like maybe 100 times, and then you want it to stop at a specific point, so then you would be using the micro steps to get it exactly at a specific point. So if you have a really specific motor, you would want the more steps. So like if you have, I don't know, 600 micro steps, you could get it really accurate. Also depends, like you may not necessarily be using it with a wheel, so it might be an arm with a large amount of torque that it's dealing with. So this is just two step motors with the Washi 3 with the driver in there, and then that's just an RS-232 serial cable. The 232 is the protocol that it uses to communicate with the computer. So that you would use that to program the step motors and tell it what to do while it's running. If you don't have the driver, basically can't do anything unless it has something that lets you turn it on and off, and then you can actually turn it on and off, but it doesn't really do you any good, except it's brushless, so you could use it in a place where you might have like a fire hazard. Oh, and the 232 protocol, it's actually interesting because you can, it's just a serial cable, and you can make it yourself. You only need to use 5 of the pins, or if you're really short on wire, you could use 3. But then you can't communicate back and forth. You can just send messages, which might be useful in certain situations. This is just something I got out of a manual just as an example of the way it communicates. The top one, like this is the digital communication. So, yeah. So the TX minus and plus, that's the transmission, and RX plus and minus, that's like the receiving. Oops. So then you have those 5 communication pins. So you have the ground and the 4 for communicating, and this is full duplexing, so you can send and receive at the same time. This particular step motor was using RS-485, so we had to make an adapter for it, but it worked pretty fast. It had a lot larger range, so you could have it in another room and control it from another room. So that was also interesting, that you can do quite a bit of things with these. This is the analog control for one of the examples that I had. So it's just powered, and then you can use the other wires for any kind of input. Like one example would be is if you had, let's use an example of a machine that moves back and forth. You could have like switches that trip it when it gets past a certain point, and those would be the inputs. So like one of them would be when it gets to the back, and it would reset the coordinate system, and once it gets to the front, it would reset it again so that it would know exactly where it is. That would just allow you to have more accuracy when you're trying to tell something to go in a different place. And that twisted shielded pair is just to account for interference. So common applications of step ladders, CNC machines, which is the really cool one that a lot of people like to play with. Machine lathe, if you're not using like your hands to mechanically use it. Robots with moving parts. I think somebody mentioned something that was similar to the Canada arm during the presentations earlier. So like if you had a robot that would go towards something and pick it up, that would definitely be you would be able to do that with a step motor. Oh yeah, and the 3-motor setup, which seems to be popular if you like want a mechanical system in a room or in a box to be able to take environmental data at any point. It would give you exact positioning information, and it would give you any kind of environmental information like humidity or temperature or anything like that. This is a really cool picture I found online. It's just a homemade CNC machine. And this thing doesn't look like it costs more than like $500 to make, and these things can cost a fortune to buy. I mean, this one just, it's just a router that prints stuff on a piece of wood, but you could do so much more with this. You could probably like make wood carvings if you were adventurous enough.
Replace that router with a laser.
Yeah, that might be a bit more expensive than $500 though, at that point. Oh, and this is the really cool video I found. I couldn't get it to download and work on other computers, so I hope this works. There are other ones, but this one was by far the coolest one, I thought.
Wow.
Like, it actually has huge moving parts. And I think they use a Lego kit for this one, but...
I almost can't see it at the moment that it changes something.
Is it seeing what,
It has sensors that can tell the difference between the different colors.
so you can have it in any starting position and it'll solve it?
Yeah.
That's right.
Wow.
And the nice thing about this particular one is that it uses God's own algorithm, which means that it's never more than 17 moves from being finished.
Oh, it's like theoretically proved that there's some. Oh,
That's right.
wow. I see how it changes the bottom one. I don't see when it's going to change. I don't see what it's doing. Huh. Like there. I missed that. Whatever's happening, I don't see it.
Well, there's other ones that are like, they look like some sort of weird maze of some sort, but you can't see it moving as well.
Yeah.
And it just looks like there's pincers coming in and turning the thing. Anyways, that was a really cool one.
Okay.
And that is it.
And that's relevant because it's using a step motor?
Yes. And sensors. And an awesome algorithm. So.
Okay. Well, great. If that's all, thanks a lot for that.